Hello everyone. So today we'll be solving this LeetCode medium problem. Find the longest substring containing vowels in even counts. So the problem states that we are given a string S and we need to return the size of the longest substring which contains each vowel an even number of times. So we need to find a substring such that उसमें जो भी vowels हैं उनका count must be even and the string length can be till 5v5. Okay, so let's see the given inputs as well. So for example, if this was the input, then the longest substring was this lead mini cover, since like each vowel e, I and o were appearing even number of times and a and u were not appearing, so they appeared zero number of times, hence they were also even. So hence the longest substring that we get in this case was this. Similarly, for this case, the longest substring is lead C, because in this E is appearing 2 times and all other vowels are not, means occurring 0 number of times. Hence these each vowel is occurring even number of times. And in this case, the complete substring is, means the entire string is our answer, because each vowel occurs 0 number of times. So this means here the output will be 6. So I hope like you get the question now, what we need to do. So what will be the brute force approach for this question? Brute force will be to like for each I from 0 till n minus 1, and then we'll start a loop for j from I till n minus 1, and for this new substring that we get, for each substring we'll find out the count of vowels, and if like count of each vowel is even, then we will update our max length with like the current length, which will be, suppose this pointer is j and this pointer is I, and the substring was from I to j, so it will be j minus I plus 1. So we'll keep, means updating our max result with this value, and yeah, we'll get the result. So brute force approach will be to iterate through all starting positions from for I from 0 to n minus 1, and then iterate through all positions j from I till n minus 1, and then count the occurrences of these each vowel in this substring that we get. And then if all the vowels have the count as even, then we'll update our max length with max length of this length, so it will be j minus I plus 1. So let's see the code as well here. So it will be like I have created this string vowel, so that we can easily iterate through this and check the current count of each vowel. Now we start the loop. This will be the starting points, I will be the starting point and j will be the ending point for each substring. We create this map to store the running count of each variable starting from I. So we'll, for each vowel we create this map to store the running count, and we increase it. Now after increasing, we need to check for this substring I to j whether all vowels are even or not. So if initially the odd count is false, and if any means vowel occurs odd number of times, then we'll make it true and simply break. And now if the odd remains false only, then we'll update longest with longest comma j minus I plus 1 and simply return the longest. So as you can see, like the complexity of this approach will be, since we are traversing through all the substrings using two loops, so it will be of the order of big of n square. And as we can see, like the constraints are till 5v5, so it will be like 25 into 10 to the power 10, which will obviously give us TLE here. Hence we like need to optimize this approach to order of like n or n log n, or something of the order of n or n log n, right? Then only it will be feasible. So what means, how can we optimize this solution? So we know, like suppose we have like we have the entire substring till 0 to I, and we had this substring 0 to j, and this was a substring j plus 1 to I. Suppose this is the, means for the current index which we are at, we need to find the leftmost value such that this substring is valid. Okay, so we need, for each I we'll try to find the the longest substring which we can get ending at this I. Okay, it may end at this, or it may end at this, or and so on. So how can we calculate this value? So for example, if we create a like visited array, visited, for each like A, E, I, O, U, for each of these variables, we try to like create a visited array of like when was the last occurrence of all these variables. Okay, but if we simply like try to create a visited, then we will not be able to know like whether it has occurred like odd number of times or even number of times, right? So we need to like think of something where we can update whether any element has occurred odd or even number of times. So what can be the logic? So suppose like while traversing, this A occurs once, so we maintain a count for this A and we increase it by 1. Now the second time it occurs, we decrease this count by 1. So the count here it becomes 1, then it again becomes 0. So initially the count was 0 only. That means count of A was 0 only. That means it denotes that A has occurred even number of times till now. Now when we increased it by 1, that means now it is occurring odd number of times. Again we decrease it. So if it is 0, that means it occurs even number of times, and if it is 1, that means it occurs odd number of times. Now we need this count for each of A, E, I, O, U, and we know that just using 0 and 1 for each vowel, we'll be able to know like how many times, means whether the occurrence of that vowel is odd or even. So let's, from this we can like try, since this only has 5 vowels and we see like we can use only zeros and ones to represent the count, so why not like let's create a bit mask, I, O, U, and a mask of this, where this will denote like 0th bit, first bit, second bit, third bit, and fourth bit, and something random, suppose 1 0 0 1 0. So this configuration denotes that A has occurred even number of times, E has occurred odd, I has occurred even number of times, O has occurred even number of times, and U has occurred odd number of times. So some random like configuration using these bits, we will be able to know and at a particular I like how many, means what are the occurrences of each of the vowels. So instead of like separately creating a visited array for each of the vowels, what we did was we tried to see like how can we store, means check whether the occurrence is even or odd, and from that we tried to see in the direction of bits, and then we tried to create a mask which will represent the count of, means each bit set or unset will represent whether it is odd or even. Okay, and on the basis of that we can like try to find out whether means whether all the vowels have occurred even number of times or not. Now how we'll do it? So I hope like the, means set unset part is clear. Set unset part, how we'll do? Suppose the first time A comes, what we'll do, we'll set this bit. Okay, so we'll set 0th bit, and second time A comes, so what we'll do, we'll unset 0th bit. That means we'll toggle 0th bit or reverse it, means inverse bit when a vowel comes. Okay, so for A we'll toggle the 0th bit, for E we'll toggle first bit, means toggle here means if it was 1 then we'll make it 0, and if it was 0 then we'll make it 1. Okay, and this is similarly for O, we'll toggle the second bit, for I will toggle the second bit, for O will toggle the third bit, and for U will toggle the fourth bit. Okay, So this is what we'll do at each step. Now, so the optimal approach of, and how we can toggle a bit, I hope like you know, if we want to toggle a bit, so we can simply like take XOR of it with the ith bit. Suppose I want to toggle ith bit. So what we'll do, I will just take XOR of x, means we'll take XOR of x with the ith bit. So if this was x and this was the ith bit, so if it was 1 initially, then 1 left shift I will make this 0, and if it was 0 initially, then 1 left shift I taking XOR will make it 1. Then we can use XOR to means toggle any bit. So using XOR operations, we can maintain this bit mask that we have created. So let's see the overall logic that we have discussed till now. So what we will do, the step 1 is to state representation. Since we track 5 vowels and each has 2 states, even or odd, hence the total number of states will be 2 to the power 5, because there are only means 5 bits, so the maximum value will be 2 to the power 5 minus 1, which is 31. So 0 till 31. So total we have 32 states, right? Now we assign each bit a vowel. So A will be 0th bit, E will be first bit, I second, O third, and U fourth. Now once we have created this bit, so let state K with a bit mask at index K. So if mth bit is 0, that means the mth vowel has appeared an even number of times so far. And if mth bit is 1, it means it has appeared an odd number of times. And what do we want? If the mask is like this 0 0 0 0 0, then that means all vowels has occurred even number of times, right? All vowels even times. So this is what we need the mask to be, then only we'll calculate it as a part of our result, right? Now how do we transition from the logic? So what do? We have the string. Now as soon as we encounter a vowel, what we'll do, we'll toggle its bit. So if it had been initially 1, then it would become 0, and if it had been initially 0, then it would become 1, and we'll toggle it for like A, E, I, O, U differently based on the mask that we have created of 5 bits. Okay, I hope this part is clear of how we'll be toggling the bit and how this mask will give us whether means all vowels have occurred even number of times. So if the mask is 0, then only that means like all vowels have occurred even number of times. If it is 1, 3, 5, now value of that mask, then that means suppose it can be like 1 0 1 0 0, right? So this represents like 2 to the power 2, 2 to the power 4, 2 to the power 3, 0 1 2 3 4. Okay, so this represents like a 16 plus 4 20. So if mask is 20, then that means A, E, I, O, U. That means A, E and O has occurred even number of times, and I and U has occurred odd number of times. So 20 represents like based on the mask we will be able to decide how many vowels have occurred even number of times, and all vowels should occur even number of times, hence the mask should be 0 in that case. Okay, so now let's see, we have seen the transition logic. Now let's try to like find out how we'll be calculating for what was the means original problem that we needed to solve was, if we are at a particular index, then we need to find the leftmost starting point such that this means this mask becomes 0 0 0 0 0, right? Then only this substring will have all even vowels. Okay, so this is what we will try to do. So how we can do it? So suppose we are at a given string and we are currently at a given index I. Now we need to find some index j on the left such that the new substring that we will be forming has a mask equals to 0. So suppose it was the index j, this was the index, okay, the j plus 1 till I. Now suppose the total overall prefix or means of this is pi, and the overall prefix or of this is pj. Now we need to find the prefix, means we need to make the prefix or means or of this as 0, right? And it will be like the mask of this will be the overall XOR and taking XOR it with pj. So what do we need to make? We need to make pi XOR pj as 0, right? Because this will means what do we get? So for j plus 1 till I, it will have some mask, right? And that mask we can get using pi XOR pj, because I represent the prefix or till ith element and pj represents the prefix or till jth element. For j plus 1 till I, will simply find it using pi XOR pj. So these parts will cancel out by XOR property, and only the XOR of this remaining part will remain. So hence we will have pi XOR pj equals to mask of what? I plus 1 till j. Okay. And now what do we need to make this mask to represent all even vowels? We need to make it 0, right? Hence what do we want? We want pi XOR pj as 0. And now if the XOR of two elements is 0, then that means like if a XOR b is 0, then that means these two elements should be equal to each other, right? Then only all the bits will be cancelling out during XOR. Okay, so this means pi should be equals to pj. And now on the basis of this, we get like, what do we get? We get pi should be equals to pj. Hence, if we are at current index I and we have the prefix or as pi, then we need to find the leftmost j such that this the last means the firstmost occurrence of the current pi. So if we are at 0 till I and the current prefix or is pi, what do we need to find? We need to find the leftmost occurrence of this pi mask that we have encountered before. Alright, so we can simply, this is what we need to do. So because this pj that will occur here is the same as pi only. So we need to find the firstmost occurrence of this pi. Then only this mask will be 0, which will represent the even. And hence once we find this j, the substring will be from j plus 1 till I. So hence the length will be j minus I only. Okay. So what do we need to do? We just simply like need to find first occurrence of pi, and then the length will be current, it will be I minus j. So it will be simply I minus first occurrence of pi. Hence at each step we'll keep calculating the prefix or, and this will be the result. So it will be result equals to max of I equals to 0 till n minus 1. This is the overall formula that we will have. And as you can see, to find out the first occurrence means to maintain the first occurrence of each pi. Since there are only how many states possible? There are only 32 states possible, 0 to 31. So we can simply create a vector int of first occurrence of size 32 and maybe mark it as -2 initially. Okay, that means like no vowel means no mask has occurred initially. Now initially the mask would be 0, and this represents like we are before 0th index, 0 1 till n minus 1. So we are at currently at this index. So mask first occurrence of 0 will be -1, right? And now we'll simply iterate from I equals to 0 till n, and based on the current value we'll toggle the current mask based on the current value that we encounter. Whether you encounter a, e, I, o or u, we'll toggle the corresponding bit in the mask, and once we get the new mask which will be pi, at I, we'll get the new mask pi, and then we'll simply check if the first occurrence of this pi is not equals to -2, then we'll update length with j minus first occurrence of pi. And if it is like, if we are encountering it for the first time, then it will be -2 only, so we'll simply like update first occurrence of pi with I. So I hope like the overall logic of why we moved to using a mask here, and how like we are using it, and using XOR, we logic of XOR, how we are utilizing for each I, we are able to find the leftmost j such that the XOR of that mask is 0, and 0 represents all even. So let's see the code as well here of this optimized approach. What we'll do, we have simply created a first occurrence vector which have initially -2. Now initially mask was 0 at my index minus, so we have made this first occurrence of 0 as -1. Now we'll start iterating. If si is a, then we toggle the 0th bit, for e first bit, and so on, as we discussed. Now for current pi 0 till I, for current pi, if the first occurrence of pi was not -2, means some pi occurs here, then from j plus 1 till I, we can get the substring with mask 0. Hence, if first occurrence of mask was not equals to -2, then we can simply update longest with longest comma I minus first occurrence of mask. And else, if it is occurring for the first time, then we'll update its occurrence with I, and we simply return longest. And as you can see, like this is of the order of n only, and this space is of the order of constant space only. So you see like how we have moved from the brute force approach to a simple big of linear approach, where we have just utilized 5, since we knew like only 5 states are possible. Hence from that we may get an idea of we can use means Bitmask here. So, and means trying all possible ways would be, only then you will be able to means conclude at this approach, because initially you must try like creating separate vectors for each a, means for each a, e, I, o, u, you must initially try to like store the occurrences. Then you will see like this will not work, means this will work, but it will be a very messy code. So how can we like simplify this code? Since we got to know like each number has only two parity, either even or odd. So on the basis of that, we can like create separate for a, e, I, o, u as well. But that will also be like a messier code. So since all fives were represented in the form of 0, 1, so what if we just simply create a mask of 5 bits? And that is what we tried to do, and eventually we were able to solve this problem. So I hope like the overall logic was clear to you. Let's try to submit the code as well and see how well it performs. As you can see, like it runs in 0ms because of the linear complexity. And yeah, so if you have any doubts, feel free to comment down and I will be happy to help. Thank you for watching.